The theory of demand. In this chapter, we're gonna derive demand function from the optimal choice that we discussed in the previous classes. And once we derive demand function, we're gonna discuss substitution effect and income effect. And using demand, we're gonna also introduce the concept of consumer surplus. And finally, we're going to derive market demand. In the previous chapter, consumers' optimal basket was determined, and we extensively discussed how we find the optimal basket. Therefore, we can tell for a given income and prices of other goods, how much of consumer will demand of X for a given price of, say, X. And this combination of given price and optimal demand or optimal choice is a point on the consumer's demand curve. Likewise, we can find more points on the demand curve for X by changing the price of X and determining how much of X the consumer will demand. Prices of other goods and income given fixed. So individual demand curve is the set of optimal basket for every possible price of good X, holding all other prices and income constant. The price consumption curve for good X can be written as the quantity consumed of a good X for any given price X. Again, this is the individual's demand curve for good X. Let me give you the example using the following figures. Remember that we discussed, suppose this is our original budget constraint. And we discussed how we find the optimal point that maximizes utility given this budget line. And in this example, it is A. So the price of this budget line reflects for X, it's going to be 4. At the same time, the optimal basket is 2 for good X and 8 for good Y. So first point is going to be mapped in the next figure as when price of X is given as 4, optimal demand for good X is going to be 2. Now suppose the price of good X decreases. Therefore, this budget line changed. In particular, slope of budget line flattened because now price changed from 4 to 2. Again, even with this new budget line, we know how to find the optimal point or optimal bundle. We extensively discussed how we find it, and we know that B is going to be that optimal point. So when price is equal to 2 for good X, optimal demand for that good, for good X, is going to be now 10. So the second point can be illustrated in the next figure as 2 that represent the price and 10 that represent optimal demand. Let me do one more time. Now price decrease even further from 2 to 1. So in that case, the slope of budget line flatter than before. And we know that the optimal point with this new price is gonna be C. And at the C basket, optimal basket include 16 number of good X and 6 number of good Y. So this point is going to be illustrated in the next figure as price of this good X1 and then optimal choice or optimal basket for good X, which is 16. So we have this 1 point, 2 point, and 3 point. And in fact, you can do it continuously and keep tracking of all these changes along these price and quantity dimensions, and that's the individual demand curve. Let me give you some remarks about individual demand curve. First, the consumer is maximizing utility at every point along the demand curve. Remember that the demand curve is nothing but the collection of the optimal point or optimal bundles given different prices. And given that it reflects optimal bundle, it means that it reflects utility maximization point. And in this sense, this demand curve is derived from individual utility maximization problem. And second, marginal rate of substitution falls along the demand curve as the price of X falls, if there is an interior solution. Assuming that these optimal bundles are all interior solutions, we know that marginal rate of substitution must be equalized to the relative price. And given that the relative price falls at the same time, to satisfy this optimality condition, it must be the case that marginal rate of substitution falls as well. Graphically, it is represented here, for example. As relative price goes down from 4 to 2 to 1, slope at this optimal point, marginal rate of substitution, remember that the slope of this indifference curve is characterized by the marginal rate of substitution. It was in this case, 10 and 10, okay, 1. When the price equal to 4, it was half. When price equal to 2, and it became quarter when price become to 1. Okay, and at the same time, this marginal rate of substitution must be equalized with this relative price, and as the price goes down, this marginal rate of substitution, slope of this budget line, slope of this indifference curve tangent to this budget line must goes down as well. And third, as the price of good X falls, it causes the consumer to move down and to the right along the demand curve because it is the utility maximizing point, okay? And the reason why the demand needed as price goes down, moving down to the right is simply because that's the direction that maximize utility. Another way of looking at demand curve is the collection of willingness to pay. So to give you another interpretation of this demand curve, let me use whiteboard. So this is the price of good X. And this is the good. And this is the demand curve that we drive. So remember that what is the meaning of this demand curve? The given price, what is the utility maximizing quantity of good X? So another way of thinking about this relationship is the following. Suppose you want to buy X0, number of good X. What is the maximum, the price or maximum money that you are willing to give up, or like you are willing to provide, or like willing to give to the firm? Okay, so according to this demand curve, and given that this demand curve reflect individual utility maximization point, as long as the price of good X is equal to P0, I'm gonna do that, because even given that price, my utility is gonna be maximized at X0. Of course, if I can get lower price than P0, at the same time having X0 number of good X, it's gonna be even better. Okay, but the point is that the maximum price that I'm willing to give up, or like willing to give, is gonna be P0. If the price is above P0, that's not my utility maximizing point. If I'm having X0 number of good X. So in this sense, this demand curve is collection of this willingness to pay for each unit, each numbers of this good X. And at the same time, given that this demand curve is decreasing as unit of good X increases, it means that the willingness to pay for the good X is gonna decrease as unit of good X increases. Now let's use a numerical example to derive demand curve. So here, as usual, we have two goods, X and Y, and price of each good is denoted by PX, PY as usual, and we have income denoted by I. Our utility function looks like this. And given this utility function, we know that either 0 number of X or 0 number of Y is not going to be chosen, because we know that we have a other point that generate higher utility. For example, like you divide half of the income for good X and half of income for good Y, that will generate utility, which is greater than 0, which is either X equal to 0 or Y equal to 0. In other words, as long as either X or Y contain 0 point, in other words, corner solutions, that point is going to be dominated by some other point, for example, like this. That means that the previous one is not utility maximization point, and therefore solution to this problem should be an interior solution. And so at the same time is the maximization point, and as you can see that marginal utility of this X equal to Y, which is positive. We know that Y is not going to be 0. Marginal utility of Y equal to X is also positive, as long as Y and X is not at the 0, we know that it's not going to be the case. So more is better assumption is satisfied. At the same time, the marginal rate of substitution of x and y is equal to marginal utility of y over marginal utility of x. And this one is going to be x over y. And as x increases, let me denote increases in this way, increases. This marginal rate of substitution between x and y goes down. So it also satisfies decreasing marginal rate of substitution as x or y, x increases. Therefore, indifference curve generated by this utility function looks like this. And we know that it is the nice looking indifference curve that we all familiar with. At the same time, now we can use Lagrange method. So let's do that. You set up the Lagrangian function as x and y and plus, and constraint is going to be I minus price of x and quantity of x minus price of y, quantity of good y denoted by y. And you calculate the first order conditions with respect to x, which generate first we do with respect to x, then it will generate y minus lambda px equal to 0. With respect to y, then it's going to generate x minus lambda p y equal to 0. And with respect to lambda, it will generate original budget constraint. And rearranging the first and second equations, lambda must be equal to px divided by y, and lambda must be equal to py over x, and this one must be equalized. And therefore, y is equal to px divided by py multiplied by x. And I'm going to put this y equal to over here. Okay. And rearrange this budget constraint. I equal to px x plus py multiplied by py px x. This one canceled out, equal to 2px x. And therefore, x equal to so let's think about the definition of demand curve. What is the definition of demand curve? Definition of demand curve is collection of px, given px, and utility maximizing x, quantity of good x. And that definition exactly same as here. So what is this x? X is the utility maximizing x given px. Therefore, this is individual demand curve. And graphically, this is Px and x. As x goes down, you can see that number of goods consumed is going to be go up. And it reflects, okay, this relationship is reflected on this line. And then you know that any combination of Px and x satisfying this is utility maximizing point. And therefore, any point on this demand curve describing utility maximizing combination of price of good X and quantity of good Y. Now let's consider the following situation. So in this example, we have this additional term for 10x. And because of that, even though y equal to 0, as long as x is positive, we can guarantee a positive utility. So unless x is not equal to 0, if x equal to 0, utility is going to be 0, therefore it's going to be dominated by some other point. So we know that x equal to 0 is not going to be chosen. But unless x is not equal to 0, y may be 0 even at the optimum. So in this case, corner solution may arise in terms of this y. So what is going to be a demand curve in this situation is especially for good y, where the corner solution may arise. To answer these questions, we're going to first characterize these individuals' optimal solution, especially with respect to y, given price and income. And given that we may have corner solution at the utility maximization point, especially for y, we're gonna make use of the following equations that we already discussed before. So if feasible for any point of x and y to be optimal, these two objects must be equalized. We already discussed why it was the case. However, under certain situation, even under certain situations, these equations may not be satisfied, even though that point is utility maximization point. So one of such example is the following. Suppose this is the case at y equal to 0. So ideally, if this relationship is satisfied at the current consumption bundles, what you can do is that you sell $1 worth of good Y, and then you buy $1 worth of good X. So by doing so, your net spending is 0, and you can strictly increase your marginal utility. But the problem here right now is that you are at y equal to 0. So you cannot sell it. You cannot make your y to be negative. Okay. So in that case, if that is the case, in other words, if this condition is satisfied at y equal to 0, that point can be an optimal if that is on the budget line. Okay, so first thing what we're gonna do is that we're gonna characterize condition under which this corner solution arise. So rearranging this equation by using this utility function that we have. Marginal utility of x is going to be y plus 10 divided by px. Marginal utility of y is going to be x, and then price of y. And at the same time, for any point to be optimal, given that more is better assumption is satisfied for this utility function, it must be the case that px and x must be equal to income minus py, y. So if you calculate, if you multiply px in both sides, you get this one. And then I'm going to replace this one. And then we're going to get so if this condition satisfied at y equal to 0 means that y equal to 0, y equal to 0, it is the condition that describes the corner solution. So in other words, py must be greater than or equal to so let me just rearrange this equation. It's gonna be py is greater than I divided by 10. And if this happens, corner solution arise, and y must be equal to 0. And what's going to happen if py equal to I divided by 10, then you know that at y, let me denote star equal to 0, these two equation is going to be equalized. In other words, y plus 10 now equal to I minus py y divided by py. This is going to be equalized when py equal to I divided by 10 and y equal to 10. And as long as, and once py is less than income divided by 10, then you know that y star is going to be greater than 0. You can verify easily in this case. In that case, the y star satisfying this equation must be greater than 0. So to summarize, if price of y is greater than I divided by 10, then when your consumption bundle that maximize your utility, y, especially for y, is going to be 0. And then all of your income goes to x. Okay, you wish you want to sell y and buy more x, but it's not feasible because y is equal to 0. On the other hand, py is greater than or equal to I divided by 10, then this equation is going to be satisfied at the equality. So just rearranging this equation in terms of y, it's going to be y plus 10 equal to I divided by py minus y. 2y equal to I divided by py minus 10. And therefore, in this case, y is equal to I divided by 2 py minus 5. So these are the solution that maximize the utility. And then graphical representation. is going to be the following. So here, this is the price of good Y. And this is the number of good Y. And then if this price of good Y is greater than I income divided by 10, we know that optimal consumption for Y is going to be 0. And but if this price goes below I divided by 10, as you can see, this relationship PY is going to go down like this. Now that we understand individual demand curve, which is nothing but the combination of given price and the utility maximizing consumption, as a next step, let's think about what's going to happen when income changes. Like the way we derived demand curve, we start from the original point A here. So this is original budget line. And we know that A is the point that maximizes this individual's utility. To derive demand curve, we varied the price. We decreased the price of good X. Okay, and then as a result, we derived individual demand curve. In this situation, instead of changing the price of good X, let's change income I. In particular, from the initial income equal to 40, let's increase to 68. Other things being equal, especially price of good X and price of good Y being equal. So since this price being equal, and since the slope of budget line is the relative ratio of these two prices, therefore the slope of this budget line remains the same, but at the same time, Y-axis increases because income increases. Okay, and we can draw this second budget line, and then we know that under this second budget line, B is the utility maximizing point, and we know that why this must be the case. And let's increase income one more time from 68 to 92. Then we're going to have the third budget line, and under this third budget line, the C is going to be utility maximizing point. So now, just looking at the first figure and then using the relevant information, we're going to make the second figure right side. So when income is equal to 10, no, not income equal to 40. Okay. Optimal demand is going to be the 10. Okay, that is the A point. So here, we're going to keep the price of good X being fixed at 2. Okay, and that's our starting point. Now, suppose it changed the price, the income increased from 40 to 68. At the same time, price of good X is still equal to 2. But in that case, optimal demand is going to be 18. Okay. So given the same price, demand increased from 10 to 18. Okay. And if we increase one more time from 68 to 92, optimal consumption increased from 18 to 24, but the price of good X being fixed. So changes in income moves our demand curve rightward, like this way. We can look at exactly same thing in a different way. So instead of using Px as y-axis. Okay, let's use it I. So in that case, we increased income from 40 to 68, 68 to 92. And then depending on this each income level, we know that the utility maximizing consumption level of X is going to be 10, 18, and 24 respectively. And this relationship between given income and utility maximizing unit of good X is called Engel curves. Okay, like the way derived the demand curve, which is the combination of given X and utility given price of X, and then utility maximizing bundle X. Engel curves is just the combination of given income and utility maximizing the consumption of good X. So in this example, this Engel curve is positive. What does it mean? It means that as income increases, consumption of this particular good X increases as well.